So here's an example of U-substitution. The antiderivative of 9x to the fourth, all divided by 3 minus x squared to the third. So again, when we see something to a power, usually we look for this. This is usually our first option. U to the n du. The antiderivative of u to the n du is u to the n plus 1 divided by n plus 1 plus c. So that's what we're looking for. That's our first option. So let's try to get this in that form. And we have the u to the n in the numerator. We've got our something that's raised to a power in the denominator, so we're going to move this up. And we've got a constant here, and it's always kind of a little bit better to get that constant out in front. So I'll move that constant out in front. So I've got 9 times the integral, and I'm going to move this upstairs. So I'm going to have 3 minus x to the fifth. But if we move it up, what do we do with the exponent? We make that negative 3. And then we've got our x to the fourth dx. So this is a lot nicer. This is a little bit more like what we're looking for to set it up to be u to the n. So now we just have to determine what our u is. So our u is whatever's raised to a power, and that's going to be 3 minus x to the fifth. So we'll let u equals 3 minus x to the fifth. And we can make that substitution. So now we have 9 times my integral of u to the negative 3 and x to the fourth dx. X to the fourth dx. Okay? Now we have to figure out how to get a du because we've got a differential of x and a variable here of u. They've got a match. So we can do that easy enough. It's easy enough to take the derivative. We know how to do that. We're all experts in derivatives. So du dx equals, and the derivative of 3 is 0, so that's going to be derivative of negative x to the fifth is negative 5 x to the fourth dx. And we're almost the same. That's my little dog baby. He's having a dream. Okay, anyway, or a nightmare. Maybe he's being chased by cats. All right, so then we have to fix this up. So this is almost a match. We have to divide both sides by negative 5. So now we have negative 1/5 du equals, and just x to the fourth dx, and perfect match. All right, so over here, instead of writing x to the fourth, what we'll do is we'll write negative 1/5 du, so we have everything else is the same. So we got 9 times the indefinite integral of u to the negative 3 and times negative 1/5, and then we have du. We're almost there. We just have to pull that negative 1/5 out in front, so we can write this as 9 divided by, and I can put the negative sign anywhere, negative, and I'll put the 5, of course, in the bottom. And that's the integral of u to the minus 3. All right. du. And now we're ready to take the antiderivative. Sorry about my penmanship there. So that's going to equal negative 9 over 5. And that's going to be u to the, if I add 1 to negative 3, I get negative 2. And I'm going to divide by that. Negative 2 plus c. And we can pull this out together, pull this out negative 2 or negative 1/2 in front, and negative 9 over 5 times the negative 1/2, and negative times the negative is positive. So I got 9 over 10. Times u to the negative 2 plus c. And what is u? U is, well, right over here. I wrote it down, 3 minus x to the 5th. And usually we don't like negative exponents, so we would write this as 9 over 10 times 1 over, or we could put this actually in the bottom. Three minus x to the 5th squared plus 2. And you could also write it in radical form. You could also write that as 9 over 10 times the square root of 3 minus x to the 5th. Oh, I'm sorry, it's squared. Excuse me. Couldn't do that. What am I saying? I was thinking 1/2. No, it's 2. So we write it like this. Okay. Hope that helps. And like I said, just go through the steps. Hopefully everything will make sense.